or the parabola because it's the most important. Okay, the next coming lessons, except Thursday. Thursday, I will use that lesson to do a bit of some revision. Okay, right. All right. So, all right. So your functions and graphs, right? You learned about functions in grade 9 for the first time. That is in terms of the linear function. Then in grade 10, you learned about 4 functions: the linear, the quadratic, which is also called the parabola, the hyperbolic function, which is also called the hyperbola, and the exponential function, which is also called the exponential curve. So you did those 4. Now, last year, you concentrated on reflection about the x-axis by the stretch factor. You also did a bit of some vertical shift, okay, but there was no horizontal shift, right? So before we go anywhere, you know the definition of a function. We did functions recently when it comes to trigonometric functions, right? Some of the basic concepts include function notation, which we also did under trigonometric functions. So you are familiar with that, right? The domain, you know that is the set of all the x values. The range is the set of all the y values. So you know that, right? I cannot treat you like uh, you are in grade 10. You haven't done functions. You did functions last year. Right? Okay, this is just a background of some of the concepts that you are expected to know before you start grade 11 functions. So you did the linear, like that. Alright, so you did the linear. Now, the basic linear function is the line y equals x. Okay, that's the basic line. It passes through the origin. It has got a y-intercept which is 0. And in this case, it's an increasing function, which is another concept that we did last year as well. So you need to know that the domain is from minus infinity to positive infinity, the range also from minus infinity up to positive infinity. Then you did the quadratic function. Now, when I teach the grade 11 functions, I'm not going to talk about the basics of the linear function because already we have discussed it under analytical geometry. Okay? We have discussed it under analytical geometry. We did it last year, we did it in grade 9. So I'm not going to waste time to repeat the straight line. Right? The quadratic function, the basic one is y equals x squared. That function, it has got a smiley face. Okay? So it has got a smiley face. Of course, you need to know the domain, which is from minus infinity to positive infinity, and the range, which is y greater than 0. Now, we are going to play around with this function here, y equals x squared. We are going to move it up, move it down. We are going to reflect it about the x-axis. We are going to move it to the left or right, which we have never done before. We have only moved the quadratic function up and down. Then the hyperbola, okay, this is the basic function y equals 1 over x. Okay, it is drawn. The two curves are drawn in the first and the third quadrant, right? Because the numerator here is positive. If it was negative, then you draw it to the second and the third. Now we'll talk about that later as well. Again, for the hyperbola, last year you moved it in a horizontal direction. That is up and down. You did not move it to the left or right. Okay, we are going to do that in this grade. Then the exponential function, again, you moved it up and down, didn't move it left or right. In this grade, we move it in a horizontal direction. All right, so today's lesson, we are going to concentrate on the quadratic function. Okay, so I'm moving on to a new heading now, the quadratic function. Now, I want you to be aware that the quadratic function in grade 11 is slightly more complex because of horizontal shift. So your heading is like the heading, the quadratic function. It is also called the parabola. Okay, quadratic function is also called the parabola. Now, the way that I'm going to teach it I'm gonna talk about each of the general forms one by one. Okay, there are three, but there are two main ones. Okay, in grade 10, you had two, that is y equal to ax squared. So in grade 10, you had y equal to ax squared plus q, right? Where the q represented the vertical shift. And then you also, this is called the turning point form. You also have the x-intercept form, y equal to a times x minus x1 times x minus x2. We are going to talk about the turning point form later on, right at the end, because we use it to find the equation. What's the second equation? This is just a recap. So it's y equal to a times x minus x1 times x minus x2. Okay, we did that last year. It's y equal to ax squared plus q. Please don't write this down. I'm just doing a recap of grade 10. Okay? I'm just doing a recap of grade 10. Right, wait. So you did this last year. Okay? Now, I want you to be aware that from now on, from today, okay, what's the date? 7. From today, forget about this one. Okay, forget about that. It will no longer exist for you. It was for grade 10. Forget about it. Okay? Your thinking now should change because you are going to introduce horizontal shift. So this, you throw it outside the window, that's grade 10 and it's gone now. Okay? But the second one, it will continue to come back because you may need it to find the equation of a quadratic graph. All right, so this is what I'm going to do first. Let's start with the general equation. The general equations, right? Now, your general equations, in this grade, the first one, I'm going to use function notation because I don't want to treat you like small babies, right? We'll start with the turning point form. I'm going to start with the turning point form in grade 10 because it involves horizontal shift. That's a new concept which I'm going to concentrate on. So it will be a times x minus p, okay, let's put a plus, squared plus q. Okay? So this is the new general formula. Forget about this one here. Okay? This is for grade 10. Okay? For grade 11, the equation changes to this. The main reason is because in grade 10, you didn't have horizontal shift, so this plus P was not there. But the plus Q was there. Okay? So that's the main difference. The meaning of the A, which determines the shape of the graph, still remains the same. The only difference is that we are going to shift the quadratic graph in a horizontal direction. Right? Then we will also talk about the general equation of a quadratic function, which is f of x equal to ax squared plus bx plus c. We'll talk about that as well. Then, third, we'll talk about the x-intercept form, which is a times x minus x1 times x minus x2. Okay, so you need to know that in grade 11, in next year in matric, you need to know these three general equations of a quadratic function. Right? I'm going to talk about each one by one, starting with number one because it involves the concept of horizontal shift. Okay, so I'll start with number one. Can I carry on?
So what's x1, x2?
X1 and x2, they are the x-intercepts. You had taught that last year.
No, we are not. Last is long time.
These two here, they are the x-intercepts. Okay? And this is called the turning point form. So if you hear me saying turning point form, I'm referring to this equation. If you hear me saying the x-intercept form, I'm referring to that, to the third equation. All right? Okay, can I carry on? Right, let's talk about number one now. So number one,
Plus q.
what?
The plus q.
Yeah.
Don't you use it?
Sorry.
X is equal to a, then you have all that, and you have to then equal to plus q.
Yeah.
So what does q do?
The Q stands for vertical shift.
So
Don't worry, I'm going to talk about the equation in more detail. Okay. So let's talk about number one. F of x equal to a times x plus p squared plus q. Right? I'm not supposed to worry myself too much because that q represents horizontal, the vertical shift. You discussed that last year. Okay? No, you can't say you don't remember. All right, let me just define them for you then. Where, let's start with A, right? A is the value that determines the shape, or you can call it the orientation if you want, the shape of the quadratic graph. Okay, so that's the A. Let me put that away, please. Then P, that's a new one now. P is a new one. Okay, it's a value that determines the horizontal shift. The horizontal shift. I'm going to talk about this separately. The horizontal shift of the graph. Okay? And I'll also talk about the shape of A, just to remind you. Okay, the smiley face and the sad face, I'll talk about that. P, I'm going to talk about it. That is the effect of P. Then Q, the value that determines the vertical shift. Okay, so these are just the general meanings of the constants A, P, and Q. Okay, yes. Right. So let me talk about the properties of a quadratic graph which has got the turning point form. Right? I'll come back to the effect of P separately. Right. So first thing, the shape. Right? So let's talk about number one, the shape. You know this already because you did the graph last year. So Number one, the shape. Now, the shape is determined by the value of A. So, if A is greater than 0, you have a smiley face. Okay, the shape will look like this, which we generalize like that, right? Then, if A is negative, you have a sad face, which we generalize as that. Okay, so you did this last year. Okay, that hasn't changed, and that won't change. Okay, so if the constant A is positive, you have a smiley face. If the constant A is negative, you have a sad face. Now you have a maximum turning point, A is negative. The minimum turning point is A is positive. Are you following that? So with the shape, let's move on to the x-intercept. Right? Let's talk about the x-intercept. So number 2, x-intercept. Remember, you get your x-intercept if f of x is equal to 0. Remember that. So you substitute y or f of x to 0. So if you have f of x equal to a times x minus x plus p squared plus q, like that. If you substitute f of x to 0, you get 0 equal to a times x plus p squared plus q. The objective is to solve for x to get the two x-intercepts. So we take the q to the left, becomes minus q equal to a times x plus p squared, and then we divide both sides by a, so that's basic knowledge of equations. So you end up getting minus q over a is equal to x plus p squared. Then you must take square roots both sides. So if you do that, you get the square root of minus q over a is equal to x plus p. Right? Then you take this p to the left. If you do that, you end up getting x equal to. Now be aware that here we have to put plus or minus because the quadratic function has got two x-intercepts. Okay, so we have to put a plus or minus there. Then, if I take the p to the left, we end up getting x equal to, okay, I can write this as plus or minus the square root of minus q over a, all minus p. So this will be the equation which you can use if you want to determine the two x-intercepts. Okay? Right? Be aware that because of this plus or minus, it's an indicator that we are supposed to have two. Be aware of that. Okay? So whenever you're asked to determine the x-intercept, you can use that equation. That is if the equation of that quadratic function is given in the turning point form. Alright? Then let's move on to y-intercept. That's number 3. Y-intercept. Y-intercept. Alright, I just want you to be aware that you don't have to stress too much about the working out. What's important is this equation. Okay? Right? Here I just showed you how you end up with that equation. Okay? Then number 3, y-intercept. Remember, you get your y-intercept if you substitute x equal to 0. So, if the general equation of the turning point is of the turning point form is f of x equals a times x plus p squared plus q. If we substitute x equal to 0, it means we are saying f0 will be equal to a times 0 plus p squared plus q. And this will give you f0 is going to be equal to ap squared plus q. Remember that f0 there is going to be the value of y. So your y-intercept is going to be given by that. Okay? All you have to do is identify the value of a, multiply it by the square of p, then you add the value of q. You get your y-intercept. Okay? Very straightforward. Right, then after the y-intercept, then you need to move on to the turning point. Okay, the coordinates of the turning point. Right? Number 4, okay, let me do it here. Number 4 is the turning point. Or rather, I'd say coordinates of turning point. Right? Coordinates of the turning point. The coordinates are given by the x value will be minus p. The y value will be q. Okay? So at your turning point, the x value will be minus p, the y value will be q. If p is negative, then it means the x coordinate will be negative. If q is positive, if p is positive, then the x coordinate will be negative. Okay? So if you're asked to determine the coordinates of the turning point, they are given by this general coordinate form. Right? Then number 5, equation of line of symmetry. Equation of line of symmetry. Equation of line of symmetry. The equation of the line of symmetry is going to be x equal to minus p. You may get a question which may ask you to determine the equation of the line of symmetry. That equation will be x equal to negative p. Alright? Right. Then from here, let's talk about the effect of p. I have already explained the effect of A, which is repetition of grade 10. P is the only new constant. So let's talk about the effect of P. Effect of P. Okay? So first point, P is the value that determines the horizontal shift. P is the value that determines the horizontal shift of what? Okay, the horizontal shift of y equal to, I'm just going to generalize it, right? Y equal to ax squared. I'm just generalizing to that form. Okay. Right, now the next point is this. If P is greater than 0, right? If P is positive, y equal to ax squared moves to the left, like in the case of the trigonometric graph. Okay? And then if P is negative, okay, y equals to ax squared moves to the right. Okay. Always remember that is the opposite of what you think, yeah, when it comes to horizontal shift. Right.
This is just a regular.
I'm in grade 11, right? But when I'm teaching the grade 11, I also tell you about what you know, and then that we are in grade 11.
Yes.
Then, but you've got any questions before I move on to examples? You can't tell me that you are so behind.
No, the one thing that then I found.
I don't know what you dread. All right. I need to tell Right. So maybe I should also refresh you on the effect of Q. Okay. I'll just refresh you, but I'm not going to. Okay, not today, but let's talk about horizontal shift to avoid confusing anybody. Right. Examples. Okay. Now you are going to sketch this now. So I want you to sketch. Right. You sketch the following graph: y equal to x squared. Do it on the same system of axis, and y equal to x minus 1 squared. You also do y equal to x plus 2 squared. Right? Now, you sketch the quadratic function. My suggestion here, uh, you can use a domain, well, say from minus pi further to pi. Can you sketch these three on the same system of axis? You can use a step of 1. Right? Can you sketch those three on the same system?